In this video, we're going to examine the normal distribution. So we begin by pulling up a distribution here, and the normal distribution has two parameters: a mean, which has arbitrarily been assigned to be 100 in this example, and a standard deviation, which is 10. The normal distribution occurs in a very wide variety of applications. Part of that is due to the central limit theorem. That's a little bit beyond the scope of this particular course, but it makes the normal a good approximation to many other distributions. We also find that variations of naturally occurring variables are approximately normal. Anything biological tends to have a normal distribution. So if you think of heights of adult males in Asia, weights of brains, the arm span, the distance between fingertips when you spread your arms, all those sorts of things, all those biological things tend to have a normal distribution. If you have a variable that is the sum of other variables, the variable that is the sum of other variables tends to have a normal distribution. Most population data tend to approximately fit a normal curve, but you'll often find that the data might be a little bit more dense in the tails. The normal distribution is used in a lot of statistical theory for the distribution of errors. For example, if you have any experience in least squares regression, you would find the normal distribution plays a key role there. The normal distribution is also a distribution of convenience. That's not necessarily a good thing all the time. It's the most common distribution that we encounter, and it's the one that we learned about in the university, and so it's the one that people often turn to. But it's not always the appropriate choice. A normal distribution spans from negative infinity to plus infinity. You can use the normal distribution to approximate many other distributions, but you have to take care that you're not going to get nonsensical numbers. For example, we have here a variable with a mean of 100 and a standard deviation of 10. If I was terribly concerned about extreme values coming up, if the variable's true value lies roughly between 70 and 140, for example, and I would be concerned about variables beyond that range, then the normal distribution may not be the best choice. Other distributions can approximate the normal at times. Here is, for example, a beta distribution. This beta distribution has alpha 1 and alpha 2 equal to 10, and I have assigned a minimum of 60 and 140, and you see this beta distribution assumes a near normal shape. Likewise, the binomial distribution approximates a normal distribution in some circumstances. I have n of 200 and a p of 0.5 here. The importance behind this is that there will be times when you can use a normal distribution to approximate a binomial or to approximate a beta. Likewise, you can sometimes use a binomial or a beta to approximate the normal. So there are a lot of distributions that converge to a normal distribution as their coefficient of variation approaches 0. Remember that coefficient of variation is the standard deviation divided by the mean. So when the standard deviation divided by the mean for a beta, a log normal, a student t, negative binomial, a binomial distribution, gamma, Poisson, chi-square, when they all approach 0, those distributions all approach the normal. So under certain circumstances, the normal distribution becomes a very nice, handy distribution to use to represent many possible situations in nature.